Good afternoon. Welcome to the Math Department Colloquium. My first request is if you have anything in your pocket that rings or buzzes, you should turn it off. Thank you. So our speaker this afternoon is Rebecca Goldin, Professor of Mathematical Sciences at George Mason University in Northern Virginia. She is also the Director of Research at the Statistical Assessment Service, or STATS, which tries to get people to think about the numbers behind the news, helps journalists to do stories quantitatively correctly, posts analyses of topics involving statistics and mathematics on its website. Rebecca earned her PhD at MIT in 1999 with Victor Gilliman. She was an NSF postdoc at the University of Maryland before moving to George Mason. Her research is in symplectic geometry, especially as it relates to Schubert calculus and combinatorics. She's here for a conference on those subjects this weekend. And she also writes about problems with statistics and quantitative reasoning in American journalism. She was the first winner of the Ruth Michler Prize of the Association for Women in Mathematics. She served on the AMS Council and chaired the AMS, American Mathematical Society, Committee on Science Policy, and I believe that she's our first colloquium speaker to have been interviewed on the Today Show.
Thank you very much. Can you hear me? Okay. Well, I guess if you couldn't, you probably wouldn't respond. Okay, so the topic I'm going to talk about is American media coverage of things quantitative. Probably many of you have seen a lot of discussion in newspapers recently about whether, for example, we should require students to have algebra in high school in the United States. And for sure, there's a lot of debate about the role of mathematics. And for those of you who are mathematics students or who know a lot about mathematics, I think you can appreciate that it's extremely important. So part of what I try to do is talk to the public about how to understand the mathematics that's in the news that we look at all the time, and how to and I try to talk to journalists a lot about how to talk about mathematics in a way that the lay people can understand, and in fact, journalists themselves can understand. So this work is work that I do with the Statistical Assessment Service, which is a nonprofit education and watchdog group for the media. And it's located in Arlington, Virginia, which is right outside of Washington, D.C., and it became affiliated with George Mason University about 7 years ago, and that's when I joined them as Director of Research. I've learned a lot about both statistics and also about the news that I didn't know before I started. And in some sense, we can all be very naive about how news goes when we're up in our ivory tower doing our mathematics. But just to kind of point out some of the many statistical concepts that come up in a very regular way. There are things like mean, median, and mode, standard deviation or variance, confidence intervals, orders of magnitude, confounding factors, percentages, absolute versus relative risk, scientific method, and my absolute favorite, causation versus correlation. Now, all of those topics you would typically see in a very beginning course in statistics. And though many people have seen them, I think that they often run a bit contrary to our intuition. And what I want to show today a little bit is how that happens and how these concepts come up. I'm not going to do examples of all of these things, but I do want to emphasize that these things are very basic. A lot of people actually have a lot of trouble with that. Both readers of newspaper articles, but also journalists themselves have trouble, yes, with basic percentages. And this is not to say everybody, but it is a very severe kind of numeracy problem that we have in communication about these things. The topics that are impacted are many, many topics. Of course, you can imagine them: economics, education, environment, government, social programs and stagnation, social stagnation, politics and polls such as the upcoming election, health and lifestyle. And I just want to sort of emphasize that this really permeates almost everything that I read at this point. I feel that I can see this in that. And I'll hopefully give you a little bit of a view on this. So I'm going to start with a very typical kind of example that I hope you find is humorous. And this is about polls that don't take into account confounding factors. So for those of you who don't know, confounding factor, when you run a poll, is that different groups of people might feel different ways about things you're trying to measure, but you need to take account for the fact that the people that you're sampling may not be uniform. And so you might do this by taking into account for race or taking into account people's income level or something like this, so that if you poll people, you adjust your numbers for who it is that you have to poll. So I'm going to first tell about a poll that started out that was done in 2008. This was around just before the election, where it said that Republicans were more satisfied with their sex lives than Democrats. And of course, this got a lot of interest out in the DC area, so people are really very excited about politics, and everybody's really excited about sex. So we found that if you ask people who is very satisfied with their sex lives, 56% of Republicans said that they were, compared to only 47% of Democrats. And were something to enhance their sex lives, 72% of Republicans compared to only 62% of Democrats. And faking an orgasm, extremely important, only 28% of Republicans admitted to this compared to 33% of Democrats. Well, that poll is pretty old, so I started looking around, and of course, it is the election coming up. Sure enough, there was a new poll that was done on Match.com saying that conservatives have better sex. And said 53% of those who define themselves as conservative Republicans said they reached orgasm every time they had sex, compared to only 40% of liberal Democrats. So these are kind of striking and, in my opinion, really upsetting sort of numbers. So you start looking at it, you say, well, what the heck? How did this happen? And you say, well, it turns out they didn't control for the compounder of gender. And in fact, more women are Democrats. So you can take all these numbers and reread them and ask, what are men saying? This is what are women saying about their sex lives, and we won't go there. There have been quite a number of polling problems that you can see, and I'm just going to give you another sample of little things that I just found in looking at this topic, of recent polls that were done and the kinds of problems that occur in them. One very recent one found that, in fact, 19% of single adults have been in a threesome. Now, before you get upset about where you stand on this, I would say this was a poll that was done by a company that specializes in adult sex toys. But it got reported everywhere. And as a matter of fact, I wanted to know how they actually conducted the survey, and they wouldn't release that information. So we've got media reports of this poll as if it stated some truth, and perhaps that may be true of the customers of this adult sex toy store. Sure. All right. 70% of primary care doctors plan to close or reduce in size their practices. This was a poll that was done among primary care doctors, and it was one of these polls that was done in light of the health care legislation that was going on to say that we have this real crisis. And it turned out that this was a survey that had been mailed out to a doctor's office. The return rate on that was 1%. The interesting thing, they even had margins of error, and the whole thing kind of described that they had 1% of people responding, which of course are probably those people who are angry enough to respond, or were planning on shutting down their practices and were just closing things down and had time to respond to a poll. So we don't really know in many polls who in fact is being polled. Another recent one, nearly 60% of kids are skipping school who are skipping school once a month are actually growing up in two-family households. This was a poll that was done trying to characterize truancy in school and show us that our biases about who in fact is skipping school are often misguided. But this is a poll that was conducted in a local mall. So it's not surprising that the kids had more structured lives than maybe many of the kids who are in fact skipping school. So these are the kinds of things that we see all the time. And I mentioned at the beginning that my absolute favorite thing to talk about is this causation versus correlation. And I put a cute little cartoon up there. I think that I used to think that correlation, which means that two things happen at the same time, actually meant that one caused the other, or causation. Then I took a statistics class, and I don't know, and it sounds like the class actually helped you understand statistics. And well, maybe I just learned the statistics without the class. They correlate. Okay. So, I think when I talk about this, usually people nod, like, of course this is a major problem, causation versus correlation, and they don't realize that, in fact, it goes, I think, much deeper than we think at first glance. So let me just give you a few examples of things that correlate well. Some of them might be causal. Height correlates with reading skills. Income correlates with success in college. Your ratio of two of your fingers, their lengths, correlates with how aggressive you are. Facebook correlates with poor grades. Facebook also correlates with good grades. And doing heroin correlates with doing marijuana. Higher taxes correlates with higher annual growth, inversely correlated with poverty rates. Alcoholism correlates with less gray matter in the prefrontal cortex. Now I chose this sort of assortment of these because some of them seem kind of silly, like finger lengths and aggression, although maybe there's some kind of mechanistic explanation going on. The height and the reading skills is a nice example of something that are both probably correlated with aging of young children. And some of them where the causality is a little bit questionable. Like maybe actually having money does mean if you're more successful in college, you don't need to have a job, say, to support your experience. Maybe higher taxes actually does cause more annual growth, or maybe annual growth causes higher taxes. And one could go on about which of these actually has something causal underneath it and what your opinions might be. But I wanted to kind of illustrate how many of them are things that happen at the same time and we don't really know whether there's some cause by them. So here's an example of something that's in the press, that came out in the press. This actually comes out every time there's a Super Bowl. There's this one group that does the same story. Super Bowl Sunday loss triggers death, meaning if you lose the Super Bowl, then there's going to be more death in your town. And here's how this was reported. USA Today said suffering a sports loss can impact your heart health. MSN said Super Bowl loss really a heart stopper for some fans. And CNN, Super Bowl may trigger heart attack. ABC News, Super Bowl, which city can better survive the loss? Researchers link defeats to increase cardiac death rate in losing city. And that's exactly what these researchers tried to do, was link these, and they made it very causal in their presentation of it and in their discussion to the media. So they found a 15% increase in circulatory deaths for men, which really lost, and 27% for women. And note that, of course, the women were typically not watching the Super Bowl compared to the men. So that might cause some suspicion. But they also found the effect was greater for older people than for younger people, though younger people were probably watching it more. The results were actually based on two sets of data, both in Los Angeles, one following a loss in 1980 and one following a win in 1984. And what they did was not compare Los Angeles to the town in which, against which they won, or the town in which the game was played, but rather they compared it to data about LA the weeks following and before the Super Bowl. So they found winning had a protective effect, death rates go down. And so what happened was that they said they just compared it to looking at the deaths immediately following the Super Bowl and then in off years of the Super Bowl at the same time period. And they wanted to avoid deaths that say happened over Christmas and things like this. And then they did the same for 1984, and they saw the inverse impact. Now, of course, there are many problems to sort of study. You could have trends that are happening over the years that are following the game, and they didn't have any control set up for those kinds of trends. They didn't compare what was going on in the losing or other winning teams' towns, which were in this case Pittsburgh in 1980 or DC in 1984. They had no evidence that the people who died even knew about what was going on with the Super Bowl. This is just this overall effect. They had a lot of multiple testing, which I'll bring up later on as a kind of thing that can really compromise your results. And they really insisted on causality. And I think when you see this kind of insistence on causality is where you know that something really serious might be going on with how researchers are trying to make sure the results are heard. So this is kind of a humorous example. I should also mention, of course, that the timing of these studies is always just so to come out just when the Super Bowl is about to happen. The next one. But though that was humorous, it's not exactly moralistic. And I think that, to me, when we really see these differences of causation and correlation, having even really people who are really smart having trouble teasing out differences, is when what I call moral and the statistical collide, which is to say topics about which we have a lot of opinions. And some of those opinions might not be nice opinions, like abortion, obesity, nursing versus bottle feeding, smoking, homosexuality, daycare, food and alcohol, pollution, crime. And so when we start having opinions about things like who commits crimes or what causes the committing of crimes, we all have these opinions. Is abortion right or wrong? is obesity the obese person's fault or not? Should women nurse or is it okay if they bottle feed? Should women work or should we use daycare? Is it okay for people to be homosexual? All of these kinds of things are where people start moralizing, and they often change the way the statistics go to meet up with their moral values. So this is actually me with my fourth son when he was just born, and I just want to give you an example of the kind of thing. There was a study that was published in the American Journal of Health Promotion, and what they found was that 32% of babies at 9 months old in the United States are what we call obese. Now, obese has a technical definition. You might say, how is that possible for a baby to be obese? And what it means is that if you look at weight charts in the 1960s in the Centers for Disease Control, you see that these children had weights that lay in the top 5% of the weight charts. And the study was just about the data. Okay, they collected the data on the weights of these babies. The study did not examine any aspect of why there was this increase in weight, what sorts of things might have instigated, which groups of people were more likely to have obese babies and things like that. There was just absolutely no discussion of that. It was just a statement that has a very interesting question in line with the national interest in obesity epidemic. So what did the press conclude after they saw this? Well, of course, breastfeeding is the healthiest choice. Exclusive breastfeeding, breastfeeding alone, not breastfeeding combined with bottle feeding prevents obesity. So you can see there's an immediate conclusion that had nothing to do with the study about how to best combat this, which was not something that was looked at in the study at all. There was one or two news sources that actually spoke to early introduction of solid foods, children eating French fries, bottles filled with soda, and things that seem much more likely to cause babies to be overweight. And in fact, there's extremely little research on this topic, and the research that's done is extremely weak. There's in fact no research that I've ever seen that actually controls for what the babies are eating, except with the exception of one small study in Germany that took into account how much dessert babies were eating, but not how many French fries, and it wasn't in the United States. All of the benefit that's attributed to breastfeeding goes away by the time the children are 3.5 years old. And so what you see is a kind of media attribution based on opinion, based on perhaps what I would call moralizing, in order to avoid looking at the important question of why it is that there are so many babies who are overweight. And as I said, it's actually very weakly predictive. Babies being fat is extremely weakly predictive of turning into young adults who are overweight. And this is a really important point as to how much we should be really concerned about this. So I'll give you one more example of what I would call moralizing. Beer and gonorrhea. I'm sure you connected these two. And I'm sure that you could think of the connection. Keep that in mind. And here was a statement that came out. Taxes on beer will reduce gonorrhea. And if you're wondering how, let me explain it to you. Well, this was actually a study put out by the Centers for Disease Control, which was reported without any criticism by the media, that claimed that 20 cents additional tax per six-pack would cut youth gonorrhea by 9%. And the mechanism is the obvious one, that children are under 21 are buying their beer, getting drunk, and getting gonorrhea. And they came to this conclusion based on data that from 1965 to 1975, of course, this was the time of the sexual revolution, there was 169 cases per 100,000 that rose up to 461 cases per 100,000, so it was a huge rise. And then the cases plummeted to 120 cases per 100,000 by 1997. And if you actually looked at the year-by-year data, you would see that in 1990 to 1991, there was a huge drop. And it was the same year that there was this big excise tax that was doubled. So there was this obvious conclusion that the tax was the reason that the gonorrhea went down. And in fact, that if you increase the tax further, you would decrease further the gonorrhea rate. And as a matter of fact, I was in college in 1991, the year this excise tax doubled. And in fact, there were huge cultural shifts that had to do with HIV and AIDS and a lot of discussion about safe sex, and it had very, very little to do with beer. Okay, so this is going on currently as well, these kinds of arguments. This is a recent study, a recent headline from the LA Times. Soda tax could prevent 26,000 premature deaths, study finds. And you can imagine again, what's the mechanism? If you put a soda tax, which is, if you buy sugary soda, that you would have to pay a little bit more, and that tax would go into some kind of city fund or state fund. People would consume less soda by being motivated by that higher price. Then those same people would lose weight, and fewer would die. So you would think in reading a headline like this that somebody did this study. They looked at areas, they compared areas with high taxes and low taxes, and in fact this has been tried. But this was not what the study was about. As a matter of fact, the study was about an economic model. And this economic model, what did it do? It assumed that increased tax leads to reduced consumption. And then it said, okay, what would be the consequences of that? So we just assumed it leads to reduced consumption, assume there's consequential weight loss, assume the consequential health benefits, and then let's see what that means financially, and what that means in terms of deaths, and that means 26,000 premature deaths. So, of course, I could assume anything would prevent people from getting more overweight and start asking the question of what the premature deaths are. And this is the sort of study that's extremely misleading because it really gives you the feeling that there was a study that looked at how taxes influence people's behavior and whether having less access to soda would help people lose weight. And it did not do that at all. All it did was talk about how much health benefits there would be, tax revenue there would be, and in fact, there are some studies that really do look at this question, compare people in different cities, compare specific groups of people given in controlled environments, and for the most part, few people are actually very receptive to small tax increases. If you double the price of soda, perhaps, but if you talk about small, politically feasible tax increases, people actually don't change their behavior very much, and to a large extent, when they're actually forced to reduce their calories from soda, they replace it with juice and milk and chocolate milk or other liquid forms that are highly fluoride. So there's very little evidence that this actually would work, and unfortunately, in reporting on an economic study without saying it's an economic study, you actually get very little information about the real problem it was meant to address. Okay, so again, I do think it's a question of moralizing when people think it's somehow a sin to like soda, it's a sin to be obese, so let's just connect these two and we'll tax the sin, and we can, and it fits in with our moral framework, and I think that's a theme that I see very frequently. Now, the next topic I want to talk about, which is very much related to this causation versus correlation, is I would say we have what I call a causal brain. We just look for reasons. It's hard for us to ever think that anything in the world actually happens in a random way. So much so that you probably spent many hours with your friend who's analyzing some situation in which you think that's just crazy, there's nothing there, but yet the person just is absolutely sure that each step of whatever happened for a reason. And I think it's actually hardwired in us, but we can debate the reasons behind it. I do think there's a huge role of randomness, and so I just want to take a couple minutes to talk about what I mean by randomness. And so I'm going to start by assuming that we have a huge urn of balls. This has infinitely many balls, but 10% of them are red. Oh, the rest are white, not red. So I've got red balls and I have white balls. And 10% are red and 90% are white. Sorry for the typo. So each of 100 people go up and pick 10 balls, okay? And they write down their colors and they return the balls to the urn. And then we start asking, well, what colors did you get? What color did you get? And you probably expect that about 10%, each person would have about 10% red balls. So if they pick 10 balls, they'd have 1 red and 9 white. But of course, it doesn't exactly happen that way. Some people will just happen to get all white. Some people might have 2 reds or even 3 reds, or even more than 3. And that's actually something that we would just expect from the statistics of it. So now let's just put another layer onto this experiment. I insisted to you that the whole process was random. But now I'm going to tell you that red actually represents something that could be random, like getting cancer, or like producing a faulty gizmo on your gizmo machine. Okay, so there are a lot of things that are absolutely random and could happen to anyone. But now imagine that these people, instead of having read, has some form of cancer that could happen randomly. And now you see somebody who has 4 different cancers. And I would argue to you that it's almost impossible for you not to think there's a reason behind that. You see, like, that person is just so unlucky, but did he smoke? I mean, didn't he do something, right? So again, there's a kind of inability for us to really perceive randomness as randomness. As a matter of fact, so much so that if you met somebody who had 4 different cancers that maybe were all randomly induced, you would probably forget about the many people who didn't have it. And you would start looking for what environmental toxin infected this person. Okay? So we are believers in causality so deeply that even when we're told something is random, we have a hard time believing it. And there were actually some very interesting experiments set up very much like this by a famous engineer who was trying, a guy named Deming, who was trying to get U.S. engineers to improve their quality controls. And U.S. engineers didn't listen to him, but Japanese ones did. And what he did was he brought all the executives who were running big plants into a seminar in which he played these experiments. And he pretended the red balls were defective, whatever business they were creating. And he started rewarding people who got white balls. And the surprising thing was how much those people bought into it. That white meant that their production plant was doing better than those people who got red balls, even though it was right in front of their face that it was a random process. Okay? So, to give one other example of the kind of thing to get our heads around randomness, I'm going to tell you about my magic penny. Okay, so my magic penny has the following thing. If I flip it, if it's H, then a Democrat will win the presidency. And it's T for Republican. If it's tails, it'll be a Republican wins. And I'll tell you that my magic penny was magic enough that it was correct for 15 out of the past 17 presidential elections. And I know you really want to know what it says about the upcoming election. But to really emphasize how special this penny is, I'm going to tell you that there's actually, if you calculate the probability of doing that randomly, it's about 1 in 1,000 chance that just by chance I can get 15 out of 17 of the previous elections right. So I hope you believe that my penny is magic. I'm sure that none of you do. But I would say if it weren't a coin, we're actually kind of an indicator, like an economy, or the party of an incumbent president, or the due approval ratings, then you'd probably think, yeah, that's pretty interesting. If I told you the economy, state of the economy or the unemployment rate predicted the election, and so let me tell you what it tells you about this election, you'd be listening. That's what's all over the news, right? But I want to kind of emphasize and say, well, right, that kind of penny is an awfully special penny, and I don't really believe you have it. But I really do have it. Let me tell you how I found this penny. I went to 1,000 of my best friends, and I put them in a big room like this, and I told them to all take a penny out, and I wrote the names of the previous 17 elections. I wrote just actually the dates of the previous 17 elections, and I told them to flip 17 times, put H or T next to each year of each election. And then I compared it to the list of who won that corresponding presidential election. And then, of course, I picked the best coin among these 1,000 coins. Now, if you do something like this, you find there's actually 70% chance of finding a coin that's as good as the one that I found. So it's not surprising at all, in fact, that I have such a magic penny. And you might say, well, that's kind of hokey. What does that have to do with the election? But I want to indicate to you that this is what's wrong with what we call multiple testing, where you put many, many statistical tests until you see something interesting. And then you say, that's something I'm going to look at. Okay, so you might say, I'm going to look at the unemployment rate, I'm going to look at the student approval rates, I'm going to look at the economy, I'm going to look at the party of the incumbent and the relationship of the Secretary of State's gender. You could do all sorts of things, but as a matter of fact, you have to correct for that. Otherwise, of course you will find something interesting. Very high probability that you will find a magic coin. And we have to kind of put that back into our understanding that randomness is coming in. Stop believing that there's a reason behind something. So to give you a sense of the randomness, I'm going to put up here some patterns. Of these 2 patterns of heads and tail flips, each one is 100 flips. Just take a look at it. One of them I invented, and the other one I created on an Excel chart using a random number generator that would flip the coin for me. And just take a look and see if you can see any patterns in these pennies. And can you tell me which one is the one that I invented versus which one is the one that came from a random number generator. Yeah?
When you say invented, do you mean like you just randomly chose?
Yeah, I was trying to fool you.
Okay.
So I was trying to say, well, if I'm going to write down a random sequence of heads and tails, what would I write down? And I wrote down a random number, a random sequence of heads and tails, 100 long. And then the other one, what I thought was random. And the other one, I actually did a random experiment, as much as a random number generator is random. So, who would vote for choice A? Who would, A?
A for what?
Choice A is the, well, oh, I'm sorry, thank you. Because that's the one that I invented. All right, who says A is the one I invented? Who says B is the one I invented? Okay, so it's almost half and half. I'd say maybe a third of you are saying that B is the one I invented, and a third of you, 2/3 of 8 are saying that choice A is the one I invented. And it is kind of interesting. What you do see, if you look at the flip data on this, is that choice A has 8 in a row. Oh no, sorry, that's actually choice B that has 8 in a row. It looks like my chart got put up. So if you see in choice B, there's T's, many T's there in the middle. There's 8 T's in a row. So if I look back here, so choice A is the blue in the front, and choice B is not labeled, it's the red in the back. So again, let me ask you, who thinks I did choice A? And who thinks I wrote choice B? Okay, now even less participation, more confusion. Now let me just say that actually there's an 81% probability that if I do 100 flips randomly, I'll have a run of 6 or more, heads and tails. Okay? So it's kind of funny. People think of runs of heads and tails as really not random. As a matter of fact, if you kind of Google random flips of heads and tails, a lot of people think it means it alternates head, tail, head, tail, head, tail. Okay, but as a matter of fact, randomness is going to have some unusual patterns that are embedded in there. And if I did 1,000 flips, of course, I would see many, many, many heads all at once, maybe even a couple times with fairly high probability. So what we think of randomness is not actually what's random. So how does this apply to something in real life? I wanted to take a moment to talk about something called value-added models. This has been in the press a little bit because of the strike in Chicago of the teachers union. And one of their issues was whether value-added models could be used to evaluate teaching. And the idea is to measure on standardized tests how students are doing, sometimes to measure how they change over the year, and then use these test results adjusted in some complicated statistical way to evaluate the progress of the kids, and then to say what the value added of the teacher is in that process. And one of the things that's really hard about this, of course, is whether the tests are actually measuring learning. And that's not what I'm going to ask about, but rather whether it can tell us about the effectiveness of a teacher, if we assume it does measure learning. Okay, so I'm going to not worry about what it means to be an effective teacher and say, by definition, it does mean improving somebody's test score. All right, so, well, let's take the kids and randomly distribute them to the teachers. And if you do that, just like the red balls and the white balls, you're going to get some teachers who are unlucky and get bad learners in their class. And you'll have some teachers who are lucky and have good learners in their class. And on a large scale, it's absolutely going to happen this way. Okay, it's a statistical truth. And so what you could have is that it's a sort of measurement that has very little to do with good or bad if you get this randomness in here. Now, people, of course, say what students aren't distributed to teachers in a random way. It's actually one of the problems of these random models, so they try to put in little variables and correct for things like income or race or other things, so that all of these corrections actually introduce more variance into it rather than less. And this is something really, really not understood by people. I think that both teachers' unions and who are very resistant to these tests and government officials who really want these tests, neither has really put the test to the question, the test itself, which is to say, is it reproducible? Does it take what we consider to be good teachers by a different measurement and judge them to be good teachers consistently? And if you try to do that, the answer is no, they don't. And the people who do research in this, who are not financially invested in this, which are very few people, many people who work on these are very financially invested, you actually find that a lot of people know about these issues, and I will mention a couple of them, the variance and the randomness, but there's a lot of problems with these tests, and people aren't reporting on them. It's not in the public discussion, though there's huge consequences for the students of Chicago in this case. All right, so now we move on to my next favorite topic, which is absolute versus relative risk, because this one has a nice example of how things can go awry in the public discussion. Absolute risk is a risk you actually take, whereas, so as an example, if you take the birth control pill, your absolute risk of a blood clot is about 1 in 15,000 per year. Actually, that's actually incorrect. I'm sorry. It's about, yeah, maybe that's about right. All right. Relative risk is actually a risk compared to other risks. So, for example, for taking the birth control pill, you can compare the women who take the pill to women who don't take the pill. They increase their risk by about 50%. All right. So the thing about this is that these kinds of statements actually have consequences. So to give an example of this, in 1995, there was a committee of safety of medicine in the UK, and they concluded that the third generation birth control pill was riskier than previous versions. And the press reported 100% increased risk in blood clots. In fact, it was true, there was a 100% increase. The relative risk, the absolute risk for the second generation was 15 per 100,000, and for those people in the third generation birth control pills, it was 30 per 100,000. So it was a doubled risk in absolute terms, but the relative risk was 100% increase. So there was this media blitz, and of course what happened is that many women understood you were 100% likely to have a blood clot if you continued on those birth control pills. People did not understand what that meant to say it was 100% increase in risk. And as a consequence, there was actually an increase in unwanted pregnancies as women stopped taking the pill. The abortion rate went up 9% in 1 year. And as a matter of fact, just for some comparisons here, if you look at the absolute risk of the deep vein thrombosis for a pregnant woman, it's quite a lot higher than being on either second or third generation birth control pill. It's 80 per 100,000. So you see people misunderstanding risk and as a consequence taking very big risks. Now, there is this huge kind of culture gap between the way scientists talk about anything statistical and the way journalists talk about it. So to give you a cute example is this cartoon having to do with jelly beans and acne. And you can see these two students who have been studying jelly beans and acne, our two scientists are discussing them. And we found a link between purple jelly beans and acne with P greater than 0.05, and brown jelly beans and acne. Also, we found no link between pink jelly beans. We found no link between blue jelly beans and acne. We found no link between teal ones. No link between salmon jelly beans and acne. And they go through, and they found no link between the yellow jelly beans. And they go on and they go do this, always with P greater than 0.05. And they continue going on, saying there's no link between the orange ones or the peach ones, the black ones, the lilac ones, no link at all between them. Forward. And here we say the green jelly beans are linked to acne. Okay, so there was one place, I lost it at this moment, where the green ones were linked to them, of all the colors. It must have been here somewhere.
Second slide.
Second slide, okay?
Fourth from the top.
Whoa.
Fourth from the top. What?
On. First one.
On the second row?
First
Oh, thank you. There we go. There we found the link between the green jelly beans and acne is the fourth on the top row. Okay, so among all the tests that are done, that's the one that is noticed in the press. And this is what, in fact, people will see, that there's 95% confidence, and only a 5% chance that this happened by coincidence, which is also a misunderstanding of what a p-value is. And the green jelly beans are now linked to having acne. The media impact is extremely great in discussing these kinds of things. As an example, in 1998, one scientist, Andrew Wakefield, published a study on 12 children, and that formed the basis of the belief that autism was actually caused by vaccination. And the press repeated this results, reported the results, even though the scientific community could not reproduce the results, try as it may. The existence of the study gave a greater voice to other studies questioning the safety of vaccination. So get that question of like the relative importance of any one person's contribution. But it turned out here's something wonderful about the journalists involved. They're the ones who actually looked into the integrity of Wakefield's work and found that he had actually faked some of his results. And not only was it one spurious result, but even that wasn't valid. And though his autism study was discredited, the media coverage continued to be, let's report both sides of the story, as if there were two sides to the story. The medical community, of course, universally endorses vaccination with very few exceptions. And right now, the consequences of that is that we have pockets of measles and croup that are due to vaccination refusal or a lack of herd effect, which have been found both in the US and the UK because of this fear of vaccinations. So to take a couple words about scientific culture versus the journalistic culture. So in science, we hear about a surprising result and we wonder what went wrong. How did I get that result? Titles of the papers that we write are meant to be informative about the paper, not conclusive of the results. Abstracts tell only part of the story, and results cannot be divorced from the methods we use to get those results. This is just what do scientists think about that work. The timeline is often months to years to get a result, and great ideas should be kept secret until they can be proven. And the media and lay people don't matter as much as scientific journals and the scientific community matters. Every result should be contextualized as to what other research was done on the topic. And of course, there are activist scientists who promote their work shamelessly. I'm certainly not trying to say that scientists are above the fray of being convinced of something regardless of what their science actually says. So let me just say also vested interests include funding sources, such as if you have National Institutes of Health funding and you know that they are interested in those kinds of results, you may just produce those kinds of results. Prestige and, of course, our belief systems. The journalistic culture is quite different. They hear of a surprising result and think that makes for a great story because it's new. Headlines are meant to tell the story. They're going to sell it and they're going to tell it. Scientific abstracts tell the whole story about the science that was done. The results are results unless there's a money trail telling the story. That's kind of the typical journalistic think about this. Journalists are on a very tight timeline. They often have only a couple days. I've heard fantastic examples of journalists calling scientists to ask about, if they can explain to them of the science behind ADFD, and they say, well, let's start with what the acronym is. You know what that is? And the journalist responds, I was hoping we could start with that. Okay. So journalists are on a very tight timeline. They often don't even know anything about the topic that they need to write on and write on it quickly. Great ideas should be shared right away before they get scooped. And one result makes for an article. And I wanted to just point out that a recent meta-analysis that looked at how journalists are reading scientific coverage, they found that the spin in the news coverage was highly correlated with spin and abstract article conclusions, which is to say that the scientists are also responsible for the sort of spin that we see in the media. They're not getting it from the vacuum. There are, of course, activist journalists who really want to cherry-pick their sources to bolster their view, and that includes a very famous people. You probably are aware of a neuroscience journalist named Jonah Lehrer, who recently lost his job at the New Yorker over a very embarrassing incident of mistelling stories about Bob Dylan. Had nothing to do with science that he got in trouble, but then they started looking over his work, and he, in fact, did a lot of cherry-picking. And earned his way up to the very top ranks of American journalism by doing this. So what can we say about data? Can we dote on it? What can't be found in it? We cannot find answers to our moral questions. We can't find answers to extremely complicated questions. we cannot find 100% certainty. And I should add that a lot of data is simply unavailable. We simply will not know the answer to many questions that we might find interesting. And we cannot find answers that take care of all of the possible confounding and bias. But there are some lessons to learn from this. And one is never overestimate the ability of poor data to give you answers. This is something that I find very frequently. People who love data, people who study data for a living, say, well, there's got to be something in there. And actually, no, that's not true. The world is a complicated place, and many things interact with each other. This is speaking very much to the confounding in many studies that goes on, regardless of polls about our sexual behaviors. The public voice is at least as loud as the scientific voice. The public voice is probably much, much louder at determining how science actually gets the lessons that are written in history rather than the scientists themselves. And consensus is extremely important, and this is why it's so important to repeat scientific studies and to make sure that we're not just getting something where one person believes something, and that's it. So you might say, why do I do this work? It is a lot of work talking to journalists, and I do it because I do think we often overestimate risks and spend a lot of time worrying about things that are not the right things to worry about, and very little time worrying about the things that actually matter in life. So in light of that, I'm going to show you a very short film after which I will finish, just a reflection of my view on life. The film is in French, but it's subtitled. Uh-oh, it's not working. I need the volume.
Try it again. It's all plugged in.
Okay, should I start again? We'll see if we can do that. I don't know how to get it all in the hand.
Au Japon, on consomme peu de graisse et le nombre d'infarctus y est plus faible qu'aux États-Unis. En France, on consomme beaucoup de graisse et le nombre d'infarctus y est plus faible qu'aux États-Unis.
Sorry. We actually sorted this out before, but it didn't seem to work, I guess.
Yeah.
Yeah, that looks good.
Yeah, it's big enough.
It's big enough. Okay.
Au Japon, on consomme peu de graisse et le nombre d'infarctus y est plus faible qu'aux États-Unis. En France, on consomme beaucoup de graisse et le nombre d'infarctus y est plus faible qu'aux États-Unis. En Inde, on boit peu de vin rouge et le nombre d'infarctus y est plus faible qu'aux États-Unis. En Espagne, on boit beaucoup de vin rouge et le nombre d'infarctus y est plus faible qu'aux États-Unis. Au Brésil, on fait beaucoup plus l'amour qu'en Algérie et le nombre d'infarctus des deux pays est plus faible qu'aux États-Unis. Conclusion, buvez, mangez, faites l'amour autant que vous voulez. Ce qui peut tuer, c'est de parler anglais.
Thank you for a wonderful talk. Are there questions for Rebecca?
Which means when you talk about controlling various factors, how that controls various.
So you asked, how does that contribute to the variance to add new factors when you control, like when you break these value-added models? Is that what you're speaking to specifically?
Yeah, and what does controlling the factors?
Okay, so when you come up with a model and you say, okay, I'm going to, you would ideally like to say, I'm going to take two groups of people who are exactly the same except for one variable that I want to measure. And I'm going to put them, and I'm going to change their behavior in exactly one way, and I'm going to measure this variable. Okay, so I might say if I want to study breastfeeding, I might say I'm going to take two groups of 1,000 women each, and I'm going to say this group you nurse and this group you don't nurse, and then I'm going to measure, say, whether their babies have higher IQ or some other output measure of this. So to control for that, so what happens though when we do that, of course, is that we can't just insist that these women nurse and these women don't. You have to actually look at what's called observational studies, so you actually see like what do women do. And the women who decide to nurse are different than the women who decide not to nurse in many, many ways. One of those might be their education level, their IQ level, their income, their race. You could just go on in many ways. So you put in corrective factors so that you could say, well, I'm going to find a way to pretend as if they were the same group by changing certain aspects of the composition of who I'm comparing to whom, so that I could try to say that I'm really comparing women who are similar to each other when I say that there's some outcome which is different for women who nurse versus women who don't nurse. Okay, so that's what needs to control for it. In the specific case of value-added models, one of the things that so there are many things again that you have to control for, but what I think is misunderstood is how that itself can add a certain amount of variance to those measurements, so that randomness effect that I'm talking about actually can increase rather than get stabilized by what's going on, so that your measurement, your outcome measurement, actually is less precise than you would have thought, because you introduce many variables for which you want to correct, and those variables themselves have variance. Any other questions? Usually I don't get such technical questions, so please don't be shy to ask a less technical question. Yeah. Yeah.
Sorry, I can't resist asking this question. Like, how much is the abortion rate in the UK rise outside of the year?
Oh, actually, I don't know, but I heard it was very consistent. It was consistent, so I don't think it was rising very much outside of that year. But to be honest, I didn't check it. You're right, I should have. To give it a good talk, I should have said that it normally doesn't rise at all, or it's very consistent. And of course, it's possible that some other thing was going on. This was something that was quite large, and maybe it was just correlated and didn't cause the increase in abortion rate. But I guess, so of course what happened is that story I got from somebody who's a specialist in reproductive health in England, and she told me of this story. And this guy did history of it, so she was kind of in the thick of it at the time, and I think there was widespread agreement that women were petrified of their pills and had thrown them all away. And that was something that many doctors were hearing, stuff like that. But I agree that I don't have a statistical measurement that perhaps that abortion rate went up, having nothing to do with those pills. Any other questions? Great, well thank you very much.